The diagram on the right shows the graph dy over dx and d square y over dx square for the function y is equal to fx. So we see it is not mentioned which one is which one. But here we see here dy over dx and d square y over dx square. So here we see here we have a straight line graph. So this one is a straight line graph and this one is represented by a quadratic function. Why? Because quadratic function we have x square and this one we have x. So do you still remember when we do differentiation? So here when we have y is equal to x cubed, when we differentiate we will get 3x square, right? And then d square y over dx square we get x. We get 6x, but I just want to show you here is the x, how x change. So from power of 3 to power of 2 to power of 1 when you differentiate. So obviously when you have this dy over dx and d square y over dx square, of course the more x the less differentiate. So dy over dx is the graph of quadratic and d square y of dx square is the straight line. So we know that our y is the cubic function graph. Alright. So it says that y is equal to fx passes through negative 1, 6 and 1, 2 without finding the equation of the function. Oh, it doesn't want us to find the equation. A, determine the coordinate of the maximum and minimum point of the graph. So how to find maximum and minimum point? So here we see here whenever we have a graph, if dy over dx, so we see here if dy over dx is lower than 0, that means the graph is decreasing. If dy over dx is larger than 0, that means it is increasing. See here the graph. But then if you have dy over dx is equal to 0, that means you have a minimum, or dy over dx is equal to 0, that means you have a maximum or minimum point. So dy over dx is equal to 0. So you see here dy over dx is represented by this graph, the square graph, right? The quadratic graph. So what happened is when dy over dx, this one is represented by y in the graph, is equal to 0. So we see here when y is equal to 0, we have x is equal to negative 1 and 1. So here the coordinate of the maximum and minimum point of the graph is, so it say it passes through negative 1, 6 and 1, 2. And we know negative 1 and 1 is the minimum and maximum point. So the coordinate is negative 1, 6 and 1, 2, which is given lah, this one. Alright. B, sketch the graph of the function. So we have 2 points, right? So we just roughly plot. So we have 6 and 2. So this is both y is positive. So I just roughly sketch here. So this one is negative 1, 6. So negative 1 might be here, negative 1. So 6 might be here. So this is here. And then I have 1 and 2. So I have 1 and 2 might be here lah. Right, so this is 2. So you see here, as this one is higher than this one, so we know that this one is maximum point. And this one is the minimum point, where the graph cannot be any lower than this. So this one is the maximum point, and this one is the minimum point. So the graph touching this one, so going down and touching this one as the minimum point, something like this, okay? Where this graph is y is equal to fx. So the maximum point here is negative 1, 6, negative 1, 6, and the minimum point here is 1, 2.